So 2005, question number 2, part D. So it says find the value theta from 0 to pi over 2. So they give us a limited domain that corresponds to the point in the curve in the first quadrant with the greatest distance from the origin. So what tells us the distance from the origin? R. R is the distance from the origin. So if you do that, your radius is that distance. So in other words, you want to maximize R, maximum radius. Now we can tell that R is always positive. We don't have to worry about negative. If we had negative, it's the absolute value, because if you had negative 10 as an R and all the positive R's are less than 10, then negative 10 would be your maximum distance, because distance doesn't care about negative R's. But in this case, all our R's are positive, so we don't have to worry about that. So where do max and mins occur? And everyone should say critical points and endpoints. You learn that in Calc AB, chapter 4, section 1, to be exact. So let's look at R. And then dr d theta, they already gave that to us actually. So you need to find the critical points. What are the critical points when the derivative is undefined or 0? Well, cosine's always defined. We don't have to worry about being undefined. So we set that equal to 0. And this is number 2. It's a calculator question. So in your calculator, I would plug this in as y1. And 0 is the x-axis, right? I would just find where it crosses the x-axis. If you plug that in your calculator, you're going to find that it occurs at one place. That's going to be at theta equals pi over 3. And you actually could have done this without a calculator if you would have solved. So you subtract 1, divide by 2, you get negative 1/2. Cosine's negative 1/2 in the second quadrant at 2 pi over 3. So this equals 2 pi over 3. Divide by 2, you get pi over 3. So you could have done it without a calculator, but since we had a calculator, I guess we can do that. Actually, a calculator would have given you an approximation and not that exact value, by the way. And so here's a question. Is that the maximum distance? Well, you need a test. And you can't say, look at the picture. Obviously, this is R0 or theta 0. This is theta pi over 2. The maximum is going to be over here, which looks like pi. You can't say that. You can't just say, look at the picture. That's not a valid way of doing calculus. You got to be analytical about it. So you have to say, hey, what's my radius at the endpoints? 0 to pi over 2, because that's my endpoints. And what's my radius at pi over 3? So you would just plug this again, y1. I would make this y1. I know you had that, but if we make this y1 in our calculator, we just evaluate y1 at 0, pi over 3, and pi over 2, and you would get 0, 1.913, and 1.571 if you plug that into your calculator. And let's read the question. Find the value of theta that corresponds to the point in the curve. They don't want the greatest distance. They want theta. So you would say, therefore, how would we write that? What's the question? The corresponds to first quadrant, greatest distance from the origin. The point that is the greatest distance I can't even write. Distance from the origin on the interval of 0 to pi over 2. I'm saying way too much. Occurs, that's the word. Occurs at theta equals pi over 3. Dun, dun, dun.